Now let's open the RobbyBasicCode.ino file in Arduino IDE. Once again, locate the file name RobbyBasicCode.ino on your computer and double-click on it to open it, or simply click on the file and then open and navigate to the specific folder that contains the file RobbyBasicCode.ino. Once you have this file open in Arduino IDE, it should look like this. Note that the first line of code is an include statement. It says include Servo.h. All this means is that we want to use the code library for servo motors. Oftentimes, the manufacturer of the microcontroller unit also provides some pre-written library of code files. This makes it easier for us to simply include those libraries in our program. The Servo.h library of code allows an Arduino board to control servo motors. Once again, it's a relatively simple program with just a few lines of code. As we discussed before, first I am declaring the number of servo motors we are using. As you know, we are using 3 servo motors. So the first 3 lines of code simply gives each motor a label. You could use any label name you want, but I encourage you to use descriptive names for the label so that it's easy for you to know what it refers to. As you can see, 3 labels or names I used are head servo, left arm servo, and right arm servo. Next, I have what we call the setup section, which starts with label void setup. This section of the program is typically used to set up the initialization code, such as specifying which pin a specific motor is connected to and setting motor position to 90 degrees using the right command. Let's review the code in the setup section. First, we are going to tell the program which motor is connected to which pin on the microcontroller board using the command name attach. It is very important that we assign the correct pin in code to match with the physical connection we made for the motors. As you see, we are now telling the program that the motor connected to the head servo, is connected to pin number 2 on the microcontroller board. The number 2 in parentheses after attach is the pin number. So head servo.attach 2 means the motor connected to the head is attached to pin number 2. Remember, that's exactly how we connected it when we were connecting the wires from the motor to the microcontroller unit. Next, we are now telling the program that the motor connected to the left arm servo, is connected to pin number 3 on the microcontroller board. Once again, the number 3 in parentheses after attach is the pin number. So left arm servo.attach 3 means the motor connected to the left arm is attached to pin number 3. Remember, that's exactly how we connected the left arm motor when we were connecting the wires from the motor to the microcontroller unit. Next, we are now telling the program that the motor connected to the right arm servo, is connected to pin number 4 on the microcontroller board. Once again, the number 4 in parentheses after attach is the pin number. So right arm servo.attach 4 means the motor connected to the right arm is attached to pin number 4. And remember, that's exactly how we connected the right arm motor when we were connecting the wires from the motor to the microcontroller unit. That completes pin assignments portion of the code. Next, we have lines of code that initializes the motors to 90 degrees using the write command. The line of code head servo.write 90 states that we want to bring the motor connected to the head to the 90 degrees position. The 90 in parentheses after the write is the degree for the motor position. Remember, the motor gears can rotate from 0 to 180 degrees, so 90 degrees is exactly halfway of the rotation range. Then you see delay 10, which basically tells the robot to wait 10 milliseconds before moving on to the next command. The number 10 in parentheses after delay is in milliseconds. As you know, 1000 milliseconds is 1 second. So if you wanted to wait 1 full second, you would write delay 1000. In our case, 10 milliseconds, which is 1/100th of a second, is enough of an amount of delay. The next line of code, left arm servo.write 90, brings a left arm motor to 90 degrees position, and then there's 10 milliseconds of delay again. And finally, the line of code right arm servo.write 90 brings the right arm servo to 90 degrees position and waits for 10 milliseconds. That pretty much completes the setup section. Please note that after each line of code, there is a semicolon. That is required as it is part of the structure or syntax of the program. It's similar to the way we use a period at the end of each sentence. Also note that this section of the code starts with symbol open bracket, and then this section closes with a close bracket symbol. This is again part of the structure of the programming language. The next section of the program is called the void loop, which starts with the open bracket and it closes with the close bracket. This is the main program that gets executed. This is the section where you write the main code that's going to make the robot perform certain actions. First, I have written the code that lowers the left arm slightly from its current position of 90 degrees. Remember, 90 degrees represents an arm straight out. I am using what is called a for loop for the arm movement. I am also using a variable h to denote a specific position of the motor. Basically, inside the for loop, int h equals 90 states that I am starting the movement at a position of 90 degrees. H++ means I want to increase the position by increments of 1, and h is less than or equal to 20 means that I want to stop once the arm gets to 120 degrees position. So this code starts at 90 degrees, issues the movement using left arm servo.write h, which positions the motor to 90 degrees, waits 10 milliseconds, and then increments the value of h by 1 to 91. It then goes through the loop and moves the motor by 1 degree since the value of h is now 91 using the left arm servo.write h. It waits 10 milliseconds and then increments the value of h by 1 to 92 and repeats the cycle. This loop continues until the h reaches the value of 120. By this time, the left arm has moved from 90 degrees to 120 degrees. So you may ask, why 10 milliseconds delay? Why not 50 or 100? Well, sure, you can use any amount of delay you want, but using 10 milliseconds provides just about enough delay to see the smooth movement of the arm. If you use too much delay, say 50 milliseconds, you will see the arm move slower. I will show you the effect of different amounts of delay when I teach you how to manipulate the code to make the robot do different things in later sections. Now that we have lowered the arm to 120 degrees position, next we want to change the arm position all the way to 0 degrees, which would be straight up. So the next section of the code does exactly that. Now, the for loop starts at 120 degrees position. H decreases the value by 1, and it goes all the way to 0 degrees. So it starts at 120 degrees, and the next time the code cycles through the loop, it reduces by 1 degree to 119, and issues the command to the motor to bring it to the 119 degree position. The next time, it brings it to the 118 degree position, and it continues the loop until it reaches 0 degrees, which is when the left arm is straight up. The next section of code creates the right arm movement. Please note that for the left arm, the 0 degree position is straight up, and 180 degrees is straight down. However, for the right arm motor, this is reversed, due to how the motors were attached. So now, remember that 0 degrees is straight down, and 180 degrees is straight up for the right arm. The for loop raises the right arm to 120 degrees. The code is pretty much the same as we used to lower the left arm. The loop starts at 90 degrees position and issues the command to bring the motor to 90 degrees and waits 10 milliseconds. It then increments the value of h by 1 to 91, issues the command to position the motor to 91, waits 10 milliseconds, and starts the loop again. It continues that until the motor reaches the 120 degree position. The next loop in the code lowers the right arm from 120 degrees to 0 degrees, which is straight down. The loop starts at 120 degrees position and issues the command to bring the motor to 120 and waits 10 milliseconds. It then decreases the value of h by 1 to 119, issues the command to position the motor, waits 10 milliseconds, and starts the loop again. It continues this process until the motor reaches the 0 degree position, which is straight down. The next section of the code creates the head movement from right to left. It starts at 90 degrees position, which is looking straight ahead. Using int h equals 0, the command head Servo.h immediately moves the head without delays or increments from 90 degrees to 0 degrees, which is all the way to the right. It cycles through the loop to issue the command to position the head motor, waits for 10 milliseconds, and increases the value of h by 1 each time it goes through the loop. It stops when the motor position reaches 135 degrees, which is slightly to the left. Next, the code creates the head movement from left to right. It starts at the h equals 135 degrees position, cycles through the loop to issue the command to position the head motor, waits for 10 milliseconds, and decreases the value of h by 1 each time it goes through the loop. It stops when the motor position reaches 0 degrees. Finally, the line of code head Servo.right 90 brings the head motor back to 90 degrees position where the robot is looking straight ahead. After it completes these tasks, there is a delay 1000, which just waits 1 second. That's all. Easy, right? To summarize, the code inside the void setup section first assigns a label to each motor, tells the program which pin on the microcontroller unit that the motors are connected to, and sets the initial motor positions. The code inside the void loop creates the movement of the left arm, the right arm, and the head. You can easily change the range of motion by simply changing the boundary values in the for loop. You can also adjust the speed of arms and head movement by changing the value of delay each time it goes through the loop. Please feel free to watch this video again if you didn't quite understand the way the code works. As I mentioned before, learning to code takes practice, so don't feel bad if you didn't understand it. I have written the code in the simplest way to make it easy for you to follow along and understand, but feel free to watch the video again if necessary.